So I think that's a good start to actually start getting into the code. Anything else before we do that?
Nope.
No. Okay. So going to assets, and the assets folder is already there when you start Unity. I didn't add that. These are just all where you put all your assets for Unity. If you don't know what an asset is, it's basically just something you're using for your project. So I'm gonna right click, gonna create. Let's make a folder called scripts. And if there are actual programmers out there, they might be like saying that's not the proper like standard way of making folders or this or that. But like I said, I'm not a professional programmer. I just do what works. So at least works for me. So you could discuss that in the chat if you want. So next thing, let's see. So I usually would make other folders like different types of like scripts, like battle scripts and so forth. But for now, I'm just going to put everything in the script folder. You can always change it later without changing any of your references. That's a really nice thing about Unity. You don't have to like find the paths to things when you move them around within the folders. It automatically does that for you. So we can change that anytime. And we're going to create. Yeah, go ahead.
So right now we're just doing the movement script.
Yep. So we're going to create a C# script, and I'm going to call this mover. So this is kind of a new kind of mentality for programming that's becoming popular. Before you would do like a movement script, like you said, where it's like the script for the movement. Now they like saying mover, so this is the script that you attach to anything you want to move. I won't go too much into that. It's just kind of like a convenience thing for once you scale the game up later.
All right.
So we have our mover script, and gonna double click this, and it should open up in Visual Studio. And now this is probably this is one point where it's gonna be really intimidating at first, because we're actually getting into code, and code can be quite intimidating and kind of foreign. But one key thing to remember is you don't actually have to memorize all the code. I just Google a lot of it. I know, so like for example, I know that there's a lerp code to like make the character move and stuff, but I don't remember off the top of my head how to do it. So I don't think there's anything wrong with just opening up our Google and finding a code that's here. So I'm trying to think about how I want him to move. The absolute easiest thing to do is just to do exactly what we were doing in the game.
Can you make that larger at all?
Maybe. Does this work?
Yep.
Okay, cool. So start is what's going to be called when the game starts. When you press the play button, anything within these brackets is going to be called. Update is going to be looking for that every frame of while the game is running. So we're going to want him to move when we press a key, and it's going to have to be listening to that key all the time. So we're going to do that in the update, not in the start. Does that make sense?
I mean, it makes a little sense than it's going to make to me in here.
Yeah, I think
just from the 5 minutes of programming that I've done, I know that there's classes, and I know that we have to tell it to attach these to the wizard somehow.
All right, hey, this is Yaz from the future. So I was looking at the video, and it seemed like we got bogged down into the code for a good half hour or so, and I think it could be explained a lot better and a lot quicker. So I'm gonna go ahead and do that now. So essentially, what we're doing is we have our character, and we want him to be able to move. And what we did in the inspector earlier, you saw we just added the transform. So like if we wanted him to move up, we just set X to be whatever it was before, plus 0.5, and he would go 0.5. I'm sorry, this is actually the Y. So Y would go up. So if you add 0.5 to the Y, he moves up. If you add 0.5 to the X, then he goes right. And oppositely, you can subtract 0.5 to make him go left. You can subtract 0.5 from the Y to make him go down, and any direction in between there, you just do both. So for example, if you wanted to go up and to the right, you just do an X, Y of whatever his original XY is, plus 0.5 and 0.5. Hopefully that makes sense. But so essentially we want to do that in code now. So first thing, we have our character, right? And what we're going to do is we're going to make a code called the mover code. And you just saw, I think in the video, you saw me create that script for that. And the mover code is going to be listening. This is not a very good ear. But yeah, imagine that's a ear. That's not a ear. That was, I don't know what that is. But it's going to be listening to the player's input. So we're going to have a player input that's going to be something like that's going to be I think in the end we end up doing two different things. One is we use WASD movement, so we have WA A S and D, and we also have the number keypad, which is 8 for up, 2 for down, 4 for left, 6 for right, and then you have 9, 7, 1, 2, 3, and 5 is to just stay in place. I don't think we add that in this video though. So when the player presses any of these keys here, the mover is going to hear that, and then the mover is going to then move whoever he's attached to. So in order to get it to move the player, all we gotta do is just take our mover here and attach him to the player. There we go. And so now the player will move. And the really good thing about this type of pattern for script is that we could have the player and we could also have the enemy use the same script. So we could have an enemy over here too. And the enemy, we want the enemy to move as well. So you could have the enemy use the same mover script. Now the astute of you might be noticing a problem here. You want to figure it out? So the problem is that the mover script is listening to the player input, and the player input, we don't want the enemy to move when the player inputs. So I don't think we do it in this video, but in the future I do edit it so that we actually have two scripts. We have the mover script and the player input script, and essentially if it's a player, we'll have like I think it's a bool. It's just like a true or false statement. I forgot exactly how we set it up, but we have so that if it's a player, it will listen to the player input, whereas if it is an enemy, it listens to the enemy AI instead. So you see here back in Unity, now this is in the future, so we have a lot more stuff going on here than we did before. But just like in the video here in the scripts folder, we have a mover script here. Okay, so here we are in the mover script. And now this has gotten a lot more complicated since the original video. I ended up changing the mover and turning it into a script that inherits from action, because in the future we're going to have movement, and we're going to have attacks and range attacks, and I think even a pass action and just various actions. So I kind of switched things around so that all actions just share the basic same script, and then you just branch off depending on if it's what type of action it is. So don't worry too much about the stuff that's written here, but this just suffices to say that when the player, or if it's the enemy AI, calls the mover script to act, and it's determined that that action is a movement action, then this mover script will call this little move function here that you see here, these two lines of code here. So it's just two lines of code. It's not particularly complicated. I'm not going to go too much into C# in these videos here. I think that I probably will make an introductory C# course, and I'll release it somewhere in the future, but I think for the purpose of our YouTube videos, we want it to be a little bit lighter, and I kind of want to keep the momentum, and I don't want to get too boggled down into explaining every single term that's being used here. But let's just, to make it simple, we'll just say, look here, we have a vector 2, and what a vector 2 is basically, if we come back to Unity, you'll see in the upper right, back where we have the transform, So this is our player here, right? There's a little icon here that's like it's like three axes colliding with each other, and that's kind of showing that there's a y-axis, an x-axis, and a z-axis to explain where something is in 3D space. And so that would be what you would refer to as a vector 3, because there's three vectors that you store in order to determine where something is in 3D space. I know that sounds complicated, but it's really not that complicated. It's basically just referring to these x, y, and z coordinates over here. So in our case, we're 2D, so we're only really worrying about the x and the y. And that's just like we were just showing. I was just showing you with the movement. If we want the character to move right, we have to add 0.5 to his x. So right now his x is 5.5. So if they put that as 6.0, then enter, he should move. Why did he not move? Did he move? Did I just miss the movement? Oh yeah, he did move. Okay, yeah, so you see him. He's right there. If I hit 6, he moves 1 to the right. And if we wanted to make him move 1 up as well, we add another 0.5 to the y. So it was currently 5.5. So if we add 1, that makes it 6, and he moved 1 up. If we want to go up 1 more to both, we'll make another 0.5 to each. So 6.5 and 6.5. Now he's up there. So essentially, all I'm trying to illustrate with this is that in order to tell the computer where the object is in the scene, it's looking at two coordinates, the x coordinate and the y coordinates. There's two axes, and those two axes are called a vector 2. If it was a 3D game, we would use a x, y, and z coordinate, which would make it a vector 3. Hopefully that makes sense. I know I can speak a little fast, and all these like numbers and coordinates and stuff can be confusing, but so that's all that is. We need to change that. That's what we're trying to change. Like what I just did with my hand here, that's what we want to do in the actual code. So back to the code. We're making a new vector 2, and we're calling it new position. So this is going to be the new place that we want him to go to after he moves. And that's going to be made up of two things: his current position plus the change that we want to occur. So you'll see here, it's game object transform position.x. That sounds complex, but really all that is it's just like a path, like in like Windows, if you're looking at a path toward a particular document in your like folders like this. It's basically just saying we're looking at the game object, which is what the script is attached to. In this case, that would be the player. And then, let me increase the size there. So that's our player, that's our game object. And then within the game object, we want to look at the transform. So this is the transform here. And then within the transform, we want to look at the position. And that's position there. And in the position, we want to look at the x, and we want to look at the y. That's the information you want to know to figure out where he is right now before we move him. So in the script, we go to the game object, transform.position.x, and then we add to that the new horizontal value we want. And then the same thing with the y, game object transform.y, and then we add to that the new vertical value you want. And this script is made so that it can take, the same script can be used for any movement. It's a little bit more complicated than what we did in the first video, but basically when this action is called, if the player had pressed something like, let's go back to here. So if the player had pressed, let's say 9. So if the player had pressed the 9 key, then that's going to tell the function to add 0.5 to the x and 0.5 to the y, which will make the character move up and to the right. Conversely, if we press like the 1 key, it will do minus 0.5 minus 0.5, which makes him go this way. If we press the 6 key, it just adds 0.5 to the horizontal, which is the x, so he'll go that way, and so forth and so on. All right, so after adding his old position with the new value that we want to add, then we need to then the script has to actually tell the player character to move. So the next line here, it says game object. We're accessing the game object again, which is what the script is attached to. And we're then accessing his transform again, we're accessing his position. But now instead of going and accessing the x and y separately, we're just saying that position, which is a vector 2, is going to be changed to our new position, which is what we just calculated above. So essentially, the first line of code is calculating where the new position is going to be by accessing his current position and then adding a new horizontal and a new vertical. And then the second line of code is actually assigning that new position to his position. And you'll see that in the game, that then translates to him being able to move freely about the game. You also notice that since this is the future, the enemies also move, and they're using the same code. It's just that in their case, instead of getting an input from the player, when the player's turn ends, the enemy AI gives them an input of what they should do. And we also have the enemies spawning and moving, and we even have attacks as well, but I'll save those for future videos to... I died. They surrounded me. But okay, so we'll save the rest of these new... You can tell there's a lot more that's gone into this since that last video, so I'm going to probably go into those in bite-sized portions in the next game devlogs coming up. Hey, just a real quick addition. So, since the code has changed so much since the beginning, I think that you've definitely got the general gist of what we're doing with the code in that explanation, but in case you wanted to have like a self-contained code to do a similar thing, I'm gonna go ahead and just make one real quick. So we're gonna do create, so this is from scratch, so you'll see the whole process, create C# script, and then we're going to call this move only me script. You could call it like a mover script, movement script, whatever you want it to be. And we're gonna make a new object in here that's not gonna be related to the other ones, so that we have just one specific script for this one. The dragon. Okay, so it's the red dragon. And on red dragon, we're going to get rid of all these other scripts. So he's not going to have the mover script. He's not going to have the only thing that he has his sprite, which is generated automatically when you put the sprite in the scene, like we did with the wizard earlier. Doesn't really, I guess he doesn't really need colliders. We haven't done that yet either. So we'll go ahead and remove the colliders. I don't think he needs a rigid body either. So there you go. So it's basically the fresh thing is the exact same state that the original part of the video was in. So so real quick, how you can attach it to the red dragon. I don't think I really talked about that. I just did it by dragging and dropping from here. You see, I clicked on mover and I pulled it over and up to the grid to this red dragon here and let go, and that added it over here. So now it's there. I actually added two now, so I'm going to delete one of them. So the other way you could do it is just directly from over here. There's a add component button here. I'll go ahead and zoom in on that. So you have this add component button. Click on that, and then we have it's probably hard to see with it zoomed in actually. So then we have this search panel here, and you could just search for what you're looking for. So I'm looking for the move only me, so MOVE only me. There it is right there. I can click on that, and you can add it that way as well. So there's two ways to add it. Once it's added, it now is going to be an empty script. I'll open it up. It'll be just like the other script where it only has a start and an update. Start is what happens at the beginning, but we have nothing being called at the beginning, so let's go ahead and just get rid of that. We have no reason. What I mean is that there's no action that we need it to take at the beginning, so we only just need it to listen for the player. An update is called once per frame, so that's going to be listening to the player after every frame. It's going to be, let me keep that there so you can actually read it if you want to. It's called once per frame, and that just means that every frame that the game is running is going to be listening for whatever you want to put in this function. And what we want to listen for is we want to know if the player is pressing a key or not. So, and if the player presses a key, we want the dragon to move. So let me just write that in the kind of pseudo code real quick. So if player presses, and for this code, let's just make it something like R. There we go. R. So if player presses R, then the dragon will move. And which direction should he move? Let's say that he's going to move up and to the left. Right? So now, in order to do this in code, we just say if, press tab twice, it gives you the basically framework for it. And then in the true area, we're going to replace that with the condition we want. So if input, we're looking for the player's input. So input dot get key. We're looking for a player to press the key down. So there's get key down, and get key up. I believe down is when you press the key down. Up is when the key returns up, and I think key is as long as it's pressed down. So I'll do it when he presses it down. Get key down, and the key that we want to get, we're going to make parentheses. We're going to put those in parentheses. We're looking for key code, is it? Key code dot, and then now we have escape space. And this is a cool thing about, the cool thing about Unity is when you press when you're writing the code, it will kind of predict what it wants you to say, what it thinks it wants you to say, what it thinks you want to say. So if you're not completely sure, you can kind of just look through here and try to figure it out. So we know we're in the right place because we're getting all these codes here, but we want the number pad. Is there a number pad? I think it's actually keypad. Actually, there you go. So keypad. Oh wait, no, we're not doing keypad. We're doing R. So we get key code. Is there R? Yeah, there is. Okay. So key code R. So if input.get key code R, oh, I'm missing one parenthesis. There we go. And so what do we want to happen when we press the R key? So we have in our little note up here, it says then the dragon will move up and to the left. In case you don't know this, when you put these two slash here, it makes that as like a comment. So the code actually isn't looking at that. That's simply for humans to be able to read. So the dragon will move up and to the left. So do you remember up is a positive vertical value. So that's going to be at x of 0.5. So let me just go ahead and mark that down. So up is equal to is going to be the current position plus 0.5, and left is actually going to be, that's a negative horizontal value, so it's going to be the current position. It's going to be the current x position. X is the horizontal, y is the vertical. Minus 0.5. And actually, let me make these opposite, because the x in Unity, that says it usually has the x value first, rather than it usually has the x value and then the y value. So just keep it in the same order. All right, so we're gonna have to get our new position like we did earlier. So we want a vector2, and the vector we're gonna call new position, and that's gonna be equal to, and we want to get the current position, right? So we're gonna get our game object dot transform dot position dot x. Oh, I'm sorry, I forgot a bit of code here. I have to say this is going to be a new vector2, and that new vector2 is going to be composed of the game object dot transform dot position dot x plus now our x we want to take away from, right? We want it to go left, so we're actually going to make it minus 0.5. And then the horizontal, the y, which is the second value in a vector, we want that to go positive. So then we're going to do the same thing. Game object dot transform dot position dot y is going to be plus 0.5. And I think I have to make these f's. Yeah, I won't go too much into that, but you have to, for if you're doing decimals, you have to put f for float. It's the difference between a float and an integer. You could Google it if you're interested. But anyways, so now we've made our new position, and just like we did in the other code, we have to assign it. So we're gonna say game object dot transform dot position is equal to our new position. All right. So if that all works, if I go in here and I hit R, we'll hit play. Okay, so we have all these other things we're just going to ignore there. We're only looking at the dragon. If I hit R, he should be going up and to the left, and he does. So that works perfectly. And then if you wanted to give him other functionality, we could go ahead and just copy and paste this and make it say now we want F to do the opposite. So now F, instead of going minus 0.5, we're going to do plus 0.5, and then instead of plus 0.5 to the y. We're going to do minus 0.5 to the y. So now we should go in the opposite direction. So play. All right, so what do we have? R and F, right? So R goes up and to the left, F goes down to the right. And since this is not attached to the player's logic at all, there's no turns being calculated or anything. It's completely separate from anything else in the game. All right, so you can see how you can just keep adding on to this to get all the directions and all the codes you need. You just copy and paste over and over again. Or you could do what you like what you saw in mine, where you can make a new function. I'll just call it a void move me. Take a new function, and you could give that new function a float for the horizontal and a float for the vertical. Once again, look up float if you're interested. It's just basically any number with a decimal. What did I do wrong here? No, figure it out in a second. Oh, I put it in the wrong spot. My bad. Yeah, these are supposed to be... Sorry, I was kind of typing too fast. They're supposed to be inside the parentheses. And these... Are they called squirrely brackets? I think the squirrely brackets are the actual function. Okay. Got a little weird there, but whatever. So, now this move me function is taking a horizontal and a vertical. And so we can just take everything we had earlier and put that inside of here now. And then in the update, well, I guess not everything. Hold on, let's go back. How much do I want? Yeah, we could take the stuff that was inside for the player input. The 2 lines of code that you saw in my earlier script as well. Put that in the move me function. And now instead of it being minus 0.5 here, we'll say that we're adding the horizontal. And then instead of it being plus 0.5 f to the y, we're saying we're adding the vertical to the y. And I just named those arbitrarily here. You can name them whatever you want. And then so now the if input.getKeyCountDown key code R, this is where the player's key is inputted. We could change this to say move me. And then for R, let's just do WASD real quick. I think it probably would be easy. So for W, we'll say that we want him to go up, so the horizontal remains at 0, but the vertical is going to be 0.5 f. And so that then plugs this 0 to the horizontal and this 0.5 to the vertical, and it adds that to the current x or current y, and you get your new position. Everything else functions the exact same that we had it earlier. But now it's just keeping things a little bit cleaner because I can take this, let me just delete this comment I had there, and I could copy this number of times, and we could have W, A, S, and D, and so the W goes up, the A is the opposite, so instead of it being 0.5, we're going to make it negative 0.5. The S is going to the left. That's a negative, left is a negative horizontal value, so negative 0.5, oh, wrong spot, to the X value, 0.5 F. And then oppositely here, and both the S and D, there's no horizontal movement, so we keep Y at 0, right? But we add 0.5 to the horizontal. And if all that did correctly, I believe WASD doesn't do anything to the player. I believe I turned that off, that functionality off, but we'll see. Yeah, cool. So now I think I did S wrong. What did I do? What's up with S? Did I not save or something? Oh yeah, I messed up. I got these two confused. So S is down, so that's down. A is actually to the left. Sorry, I got those confused. So minus 0.5 F. There we go. Okay, so now if we go back in here, and that's just a really easy way. Either way works. It's the same end goal, and it's the same end, but This allows you to just use the same code. This same 2 lines down here are used by all of these up here, as opposed to having to copy and paste the whole thing every time. I mean, it doesn't really matter that much. Anyways, I said I would. I actually redid this to prevent getting too bogged down into code, and here I am over explaining things again. Thank you so much for watching up to this point. I know this was a bit of a long one. I'll try to keep them more bite-sized in the future. So until next time, live boldly and be creative. Yoroshiku!